In the next couple of videos, we're going to look at network models. So some people call them graph models, but often when we think of graphs, we think of histograms and bar graphs and pie charts. So other people call them network models. But then again, when you talk about network models, some people think about neural networks, and this is not neural networks. So you can call them graph models, network models, or graph algorithms. What we're talking about is we're talking about how individuals or events interact, and using a model of interactions between people or events to represent how information is shared, how diseases spread, how people move. So for example, when we talk about network graphs, we're talking about social networks. Who do you talk to on social media, and who do those people talk to? We can identify influencers, for example. We can look at the spread of measles or COVID-19. We can look at the spread of misinformation. And we can also look at the movement of people, because when we look at airplanes and they go from airport to airport, that is a network. So a network consists of nodes. We have individuals or events in the network, and we're going to represent them as circles. And then we have edges. These are the connections between the nodes. So here we have a network graph, and our circles here are the individuals. Maybe these are people who talk to each other. Maybe these are airports and planes fly in between. The edges are the lines that show the connections between the nodes. So this is the sharing of the information or the movement of materials or the infections, whatever we got here. Now, when it comes to our network graphs, we can have it show weight. So we can show the strength of the connections here. So perhaps this is a person, and there's a 60% chance they're going to talk to this person, a 20% chance they're going to talk to that person, or the part my face is covering up, maybe there's a 20% chance they talk to that person. But then when you look at who this person talks to, they only talk to this person. And who this person talks to, they only talk to that person. So we can also use network graphs, for example, to represent organizational structure. That is, who reports to whom within the company. So you can think of it as the org chart for the company. Now, we can also show on our network graphs direction. So how does the information flow? If this is an org chart, for example, in a highly hierarchical organization, highly centralized, highly hierarchical, then here's the boss, and the boss gives direction to middle management, and middle management gives it to the peon below, the employee. And here you can see the direction of the flow of information. It's all down, okay? But if we're using it to represent, let's say, movement of airplanes, right? We can have one move one direction, move another, or maybe it's the spread of information as it gets passed on. So you can have direction or you can not have direction in your network. There are different types of networks. So this one that you see here is a small world network, or SWN model. Notice that most of the interaction happens in a small network with a small group. And that we have high clustering coefficient here, right? So these people group together and they're a community. They don't really interact much with everybody else. Okay. So when it comes to who you talk to and how far you go in terms of talking to people, there is low distance in terms of that communication. Really, you just talk with this group here. And what we see here then is that this particular group is then connected to another little group that's connected to another little group. Okay, so most of the interaction is in these small communities. In comparison, a scale-free network, an SFN, has a few highly connected nodes. So notice these communities are here, but they all get their information or share based on this one high influencer. So this would be like on social media, you have an influencer that spreads information to all these different groups. Okay, so it's a hub. We could also see this, for example, with airlines. So there's let's go back. Here's our hub. So Denver is the United hub. And then if you want to fly to Missoula, right, then you have to fly to Denver to get to Missoula. You want to go to San Antonio, you go to Denver, and then, right? Like, so the smaller towns all have to connect to that main hub to get to other areas of the country. Compare this to the random network. So this bottom one here is a random network. And this one here, there's really no pattern. You can talk to many people. You can talk to a few people, right? This person only talks to one person, but this person talks to four. And so you can see that there's not a clear pattern. It's just kind of random. So there are different types of networks that we want to replicate. And when we look at these different types of networks, we can do a couple different things with them. So one is to look at the flow of information. If this person has information, who does it go to? Then who does it go to next? We would use the same type of thing to look at spread of disease. So if we have a case of measles in Calgary, then who is at risk of getting measles? Where's the next case? Where's the next case? We can trace them back, and it's in the attempt to isolate it and prevent the spread of measles across the country. So we want to identify the network. We also use this network models to look at supply chains and the businesses that interact with each other. What company do you sell to? What companies do you buy from? And so we can look at networks in terms of logistics and supply chain management to see how information and materials move across the network. And then we can also look at networks in terms of centrality and how much information is shared by whom, who has the greatest influence. And one of the applications there is to look at organizational structure. Okay, so we're going to be looking at some different metrics, and most of these metrics are centrality. So the idea here is that we are looking at how centralized, in particular, we can look at how centralized an organization is. So if this is an org chart, how centralized is the organization? And we would look at then in terms of how many contexts different people have. We would look at how much influence they have on other nodes. We look at how many ways a node is connected to another node, right? How many people do you have to go in between? These are different metrics for a centrality. So let's take a look at some of them. Let's start with number of contacts. So if we look at this particular chart here, this has this key person in the middle. So maybe this is the boss. And then these are different departments. And so this is maybe the HR department and the two people that work under the lead for HR. Maybe this is the marketing department and those who work in between. So the middle management has lines connecting them. They talk to each other. Maybe there's a general meeting of the managers. And all the managers chat with the lead. And then we have these different departments that have workers in each. So if we're looking at degree centrality, we're looking at who has the most contacts, who has the most edges coming from their node. So notice, for example, if I go back here, this particular node here has 2 contacts. This person right here has 1, 2, 3, 4, 5 contacts. And the person here in the center has 1, 2, 3, 4, 5, 6 contacts. So where is the degree centrality? Who has the highest degree of contacts? That's this individual here in blue who is connected to 6 other people. Okay. Then there's what is called eigenvector centrality. This is the amount of influence of a node. So who has the most influence on others, which is going to be based on the number of contacts, but also the number of contacts that the other contacts have, right? So notice here, this person really dictates policy within this organization because they tell all these other department heads who then pass it on to their other employees. So this person is the center here of this organization because they are the one which then provides the information that then gets passed on to others. Okay, so that is our eigenvector. Then we have closeness. Closeness is how many ways a node is connected to another node. So to find our closeness coefficient or our closeness score, we take the number of nodes in the graph, which in this example here is 5, and we subtract 1 from that. And then we divide by the sum of the distance to all the nodes. So we're finding how many ways a node is connected to other nodes. So if, for example, you are this person right here, there is 1 to talk to this person, there is 1 to talk to this person, and 1, 2 to talk to this person, and 1, 2 to talk to this person. So their closeness coefficient for this person up here is 0.67. That 1, 1, 2, 2, we take 4 divided by that, we get 0.67. This person here, if they want to talk to this person, it's a 1, this person, it's a 1, that person's, it's a 1, and this person, it's a 2. So we take 4 divided by 1 plus 1 plus 1 plus 2, you get 0.8. Notice it's more than that other node. So this person has a higher closeness or a best closeness because they are closer to the other nodes. They don't have to go through as many nodes to talk to people. So they are more connected to the other nodes. So we look at how many ways a node is connected, right? Now, in terms of betweenness looks at how many nodes you have to go through to get to a node. So it's not just part of the formula. It is itself just the numbers we're looking at. So here we are looking at betweenness. How many nodes do you have to go through to get to a node? So notice that if this person wants to talk to this person, they have to go through the blue dot. If this person wants to talk to this person, they have to go through the blue dot. This person wants to talk to this person, they have to go through the blue dot. So if you have high betweenness, then you're the node that everybody has to go through to talk to any other node. Okay, so we're going to take a look at how we can calculate these in Python. Now, one thing to mention if we're using this for org charts is that if you have a low degree of contacts, so there's not a lot of people you interact with, you have high betweenness, so people have to come through you, but you have low closeness, then you are a highly centralized organization. So think about the traditional org chart. Here's the boss, and then here's middle management, and the workers don't talk to each other. They have to report to managers, and workers can't talk to the boss. They have to go through the manager. That's a highly centralized organization. There's a low degree of contacts. You don't actually have a lot of people you get to talk to. You have to go through people to get to things, so a high betweenness and then a low closeness. Compare that to a more flat organizational structure. Let's say there are 4 people, they're all equals, they can all talk to each other, in which case there's a high degree of contacts because they can all, I should have put a line here, they can all talk to each other, so everybody has contact with everybody else. There's low betweenness because you don't have to go through someone else to get to them, and there's high closeness. They can get directly to anyone they want to talk to. So we can look at and evaluate the network model to see how centralized our organization is or how flat the organization is. And we'll take a look at that in another video. Before we leave this topic though, those aren't the only metrics that you can use for analyzing your network model. In addition to centrality, we could simply look at the length of the path to talk to someone. We could look at the size of the network, so how broad is it in terms of breadth, crossed, how much depth is there in terms of that hierarchy. And we can also look at density versus sparsity. So if we look at, I'm just going to move my face. This one here on the left, this is very dense. Everyone interacts with everyone else. Lots of edges. A more sparse network like this one, each person only interacts with one other person. Not a lot of edges. So we can look at that communication here. Is there a lot of interaction between, or is there very little interaction between these events or individuals? And then we have cohesion. So can we identify subgroups or clusters? And so, for example, if we go back to some of the early ones here, we could identify these communities or clusters, and so we can actually label them. And so we're using this here for cluster analysis. Now, network And graph models are becoming more and more popular. In fact, there's a whole area of neural networks that uses graph models to do it. We also are seeing the use of network models not just in supply chain and business management, but you can also use network models for image recognition and image manipulation, because we can look at how pixels and parts of an image are kind of clustered with other parts of the image and how that information kind of interacts with other parts of it. So we are seeing more and more networks and graph models being used throughout machine learning. And in fact, the new area for generative AI is to use graph and network models in the generative AI models.